Welcome to Reality Creative Video. I'm Hermes. Believe it or not, there's about 3 different video shows on this desk right now. Hopefully I'm going to do all 3, one right after another, like a machine. But we'll see. Maybe only get one done. It's a big process doing videos. You have to, at least by yourself, you have to shoot the video, which takes 10 or 15 minutes, depending, or longer if you mess up and you got to reshoot the whole thing. Then you have to edit the video. Could be over, depending on the content I put in there, could be over an hour or 2 hours. Could be 2 hours or 3 hours. Some videos I've spent 5 hours editing, trying to get all of the little things in there that you see in my videos, popping up, doing things all over the place, collecting those videos, making the other captions. I mean, my goal would be to do a video a day to all of you. I love talking to all of you. But, you know, doing a video a day and producing a video a day and then doing all the physical things that come along the way, to me, seems like an impossibility. I actually don't know how some of these YouTubers do it, except that they must have help in the background. That's the only conclusion I can come to. How they release a video a day. But I mean, that's my ultimate goal, was to release a video a day. And now I'm lucky if I get a video a week. Now, I've done some shorts this week, so I'm trying to make up for it. Shorts are pretty good. They're easy to do. I usually, if I'm in the lab and I'm working on something, I can grab the camera on my phone, take like a 10 or 15 or 20 second video, and then quickly put that together as a short and get that uploaded. So at least you kind of have an idea of what I've been doing during the week. And, that's what the shorts are, basically, that I've released over the last few days. The numbers on the shorts are, like, bewildering. I mean, the copper short got lots and lots of hits. Lots for me, anyway. And then the video on gold, the short on gold right after it, which is basically the same kind of video, nobody watched. So this is the whole YouTube watching thing is a mystery as well. As far as, and colloidals are a mystery too, let me tell you. So, we got the mystery of YouTube and we got the mystery of colloidals. But I enjoy colloidals. I love making the videos on the colloidals. I love experimenting and exploring the colloidals. And all this week, that's what I've been doing. 2 weeks, week or two, I've been doing. I've been exploring, basically, like you guys know, plasma arc. Because that's the new orange. That's the new thing, So I got to go with the new thing and where the energy is. And that's where I'm getting all of the energy is being forced, not forced, but descending upon me with ideas and stuff, perfecting this plasma arc. And the reason I've released these videos, the short videos, the gold and the copper, was I had some feedback that people were unable to get the little 24 volt, $30, 10,000 kilovolt electronic transformer to work. And I wanted to show you guys, because there ain't many people doing this stuff out there. I wanted to show the few of you that are doing this high voltage stuff, or trying to do this high voltage stuff, which is very dangerous, and you really need to know what you're doing. But I wanted to show you that it is possible, that it does work with that transformer. I'm able to do it myself. The main breakthrough, though, is the top with that. The glass tubes. If you've seen in the last videos, I've modified my top, my V-top, okay, I call it, for arcing, and I put glass tubes in here to isolate the metal from the liquid. That has worked really well. So much so that I cooked all my most of my metals. I cooked with high voltage platinum. I went crazy. I cooked the copper. This is very interesting with copper. This is colloidal copper plasma, I'm calling it. 20 parts per million, according to the microscope. I did not actually measure the rods. This was just to see if the stuff worked. I wasn't interested in how much material I was using. I wanted to get a 20 parts per million solution on all my metals on the microscope and then go from there. And so this is copper. 20 parts per million. It's perfectly clear. Now this is copper with low voltage electrolysis, where we use the sodium citrate and the citric acid to create copper cyan and copper green, or molecule C1 and C2. And you'll see that this is the traditional bluish kind of stuff, cyanish kind of color. Of course, with colloidal platinum, with colloidal copper, or any of the colloidals that are done with plasma, with a plasma arc, there's nothing involved except distilled water. In fact, if you put anything in the water, you can't get a plasma arc. And that's something else that I had learned. Perfectly pure, fresh distilled water is what you need. And make sure the beaker is absolutely clean. If you leave colloidals behind in your beaker, which if you've used it for different colloidals, those colloidals will go into the mix and they will cut down on your conductivity, because as the colloidals burn and go into the solution, the conductivity of the solution goes up. You get metal going into the solution, the conductivity goes up, it gets harder to create the plasma arc. I haven't extensively tested the new top. This new top with the glass tube seems to be fairly phenomenal in cooking colloidals, way past what I used to be able to do with my little, electronic transformer. So as you can see, it's doing a great job. And as I began, when I started this rant, I've cooked the copper, which is clear. Okay, I've done titanium. That's absolutely clear. And titanium seems to be much more, plasma titanium is much more stable than regular titanium. Not to mention you don't waste an entire rod. I think I spoke about that. As you know from the shorts, I was able to cook gold with the plasma arc and using the new top. And that gave me a weird color. It gave me a light grayish, purplish color, and I'll show you a picture of the final color that's settled in on here. I don't have it on the desk. It's actually in this bottle here. So, and that cooked with, we have to cook plasma arc with nothing in the water at all. Now, when we do colloidal gold, we put stuff in there in order to force gold to a ruby red color. And to be perfectly honest, when I was cooking gold a few weeks ago, by mistake, I was trying to add flavoring to it. And by mistake, I added too much flavoring and I got purple. You can see they're very, very close together. This is ruby red, this is purple. So, I had the purple and I started taking the purple. And to be honest, I didn't really see any difference between the ruby red and the purple. I still had the limitless effect, even taking the purple. So, the hype around ruby red may be there may not be enough research there. In other words, there may not be any difference between purple and ruby red as far as the effect in the body goes. So, brings me to the point of the plasma gold being this grayish, purplish color. That is the natural color, if you're not doing anything except creating a plasma arc, that occurs in nature. In other words, that's the color you probably would get from a lightning strike if a lightning struck some gold and melted it into the water. It would probably be that color. And that's probably, the color that our bodies may be used to actually having. So we may not need the ruby red, but I am going to see if I can explore how to get a ruby red without doing anything. But the only thing I could suggest that I'm going to try is I'm going to try heating the solution to like 80 degrees C, and then getting my plasma arc going and see if that gives me the red molecule. But to be perfectly honest, I've been testing the gold that I cooked, the plasma gold, and I am really impressed with it. I think it's just as good as our ruby red that we cook with low voltage electrolysis. Might even be a little bit better because it doesn't have the chemicals in it. They're all household chemicals that we use, but it's a cleaner solution because it's just colloidals. Okay, so I cooked stainless steel. Now, stainless steel is a metal, as you know, and it contains iron, chromium, and nickel. So I cooked stainless steel with plasma arc. Cooked wonderfully, and it cooked clear. Again, I don't have it here to show you, but anyway, stainless steel in low voltage electrolysis method will cook. This is the color it will normally turn out to be. Kind of a orangey brownish sort of thing. So that cooked clear at 20 parts per million in the microscope. So that's an interesting difference there. Platinum was virtually clear. Platinum is clear in low voltage electrolysis or lightish brown, and it really in platinum in plasma arc was clear, and if I brought it up, it started to have a lightish brown tint. So that kind of jived. So some of the colloidals, the colors difference between the low voltage method and the high voltage method coincide, and others don't actually get along. Zinc. I didn't think I'd be able to do it. I was able to cook zinc. Even though I didn't do a short on it, I was able to cook zinc in low voltage, in plasma arc. And it cooked really well, I'll have to say. In fact, I have trouble with zinc. I have trouble that I can only keep zinc about 30 days and then it starts to separate. You get little white flakes in here with low voltage method of zinc. And I'm wondering if I'm going to get those flakes with the plasma arc. I'm betting I don't get any flakes with the plasma arc. Even this, it's got a bunch of flakes in it, and this is the low voltage version of it. So, but I won't know that for another month. I only just cooked it a few days ago. I'm going to keep my eyes on that and see if the zinc actually is more stable through plasma arc than low voltage electrolysis. For you guys, it doesn't matter. You know, if you're consuming this stuff right away, you make enough for yourself for 30 days. I would not make any more, you know, if you're consuming the colloidal yourself, I wouldn't make any colloidal that you're not going to use in 30 days. Because even the gold will start to unravel. After about 60 to 90 days, the ruby red gold starts to unravel. The low voltage method. The high voltage method, we're going to find out how long this stuff lasts. It may not unravel at all. I'm tending to think it's not going to unravel at all because the process is different. And I'm still working on the theory of how that process works. And maybe we'll have a show. I'll have a show on that once I understand it better. The difference between how low voltage electrolysis creates a colloidal and how high voltage plasma arc creates a colloidal. But I need to understand the plasma arc process a little bit better, so I'm working towards understanding that. That's maybe a future show down the road. And I will talk to you again soon.